Well, thanks everyone for coming to this. What we're going to do is go through some basic Linux commands. And it is a type of, some of you were mentioning coding. It is a type of coding, but more than that, it's manipulating the operating system. So with these sorts of commands through what we're going to call terminal, and terminal is just like that you envision an old display terminal with commands that you're writing from back in the day. This is what you are working with. It's in a window now. And the terminal is a substitute for using the GUI interface. GUI is the graphical user interface, what you're familiar with Windows and other things. And you might ask, why would you ever want to use a command line when it's so easy to click around and use a graphical interface? And there's a few reasons. One is that you can often access commands that are not present in the graphical user interface. So you actually have more capability to do things. Another is that you can script. So there's something called, the language is typically referred to as bash when you're working in a Linux terminal environment. And there are things called bash scripts. So you can, we're not going to get into that right now, but you can write a sequence of the commands that we are going to do. And it can take, for example, the output of something. It can then put it through a program that parses it break it up into different parts, and then make it available to another program for charting. So it's the kind of tools that can link together different elements of software. You can automate different routines. And the third reason would be you're seeing a lot of use of things like Raspberry Pi, which is a small, independent little computer, which can run in various locations on small amount of voltage and can be deployed in all sorts of interesting ways, but is typically doesn't have the whole apparatus of a screen and a keyboard when you're putting it out in the field. And through Linux, through the bash interface on terminal, or terminal on Linux, you can manipulate it. You can interact with it. You can change settings, and so on. So I got a question in the chat. Would bash script be like a DOS bash batch file? Yeah, I think so. I haven't messed around with DOS in some time, but as I remember, a batch file would have a series of commands, DOS commands, that would be executable, and a bash script would be very much analogous to that. So so Linux itself, just to give you a little bit of context, has a bunch of different distributions. So there are, and by distributions, there's Linux at its core has something called a kernel, which is a incredible piece of software that's very low level and navigates or negotiates with the hardware how the sound card works, how all of the lowest level of hardware operates. And so that's managed by the kernel. And on top of that is a layer which has the file system and other key elements. And on top of that is your GUI or your visual elements and other packages of software. So you can think of, when you look at Linux, it's not like Windows or Mac where you just have sequential versions. You actually have this whole garden of different varieties of Linux. And so they may share a common kernel, but then on top of it, there's something called Debian, which is a whole a family of Linux versions that people use. Some are specialized to be really lightweight and to be put onto a device like a Raspberry Pi. Others might have a whole bunch of software for a desktop. Others might be more oriented towards a server or doing certain scientific work. So Debian, that first layer, is going to be some choices that the developers have made about what basic software is included on that file system. So for example, something called a package manager. And the package manager goes and gets software from a library and it pulls it down. And it's always going to pull down the same ones. And it might have dependencies. It might require other software to function appropriately, and it will pull those down as well. So that's managed by the Debian level. Now the folks there's people that have built stuff on top of Debian. So in addition to Debian, now they're saying, for my package, I want to include a bunch of other elements of software. And Ubuntu is one of those very common sets of standard pieces of software that sit on top of Debian, that sits on top of the Linux kernel. So when people say Linux, they can mean a lot of things. Fundamentally, it's the core kernel file system. In this case, we're going to be talking about Ubuntu. And the way we're going to, so if you're working with a Mac and a lot of other systems, you can now actually access terminal and access that there's an underlying Linux system. But to get some consistency, what we're going to use is Code Anywhere. And what Code Anywhere does is it allows you to create a disposable instance. So in the cloud, it will produce a virtual computer, and that virtual computer will give you access to the terminal. And that's something we can practice on. They provide 45 minutes, or was it an hour, for free. And so you guys will be able to use it during the session. You get free every day, and you can renew and practice. If you're a MakeHaven member, you can send me a message, and we have a certain number of seats that we can provide, and you get unlimited time using the server and some other features. So without further ado, I'm going to go into it. If you haven't created a account already, please create an account at Code Anywhere. Any questions on the beginning introduction that I gave you? Okay. So in a moment, you should start seeing a interface. This is the Code Anywhere interface, and it's called the editor. So you go into the editor. It's a Code Anywhere /editor. And what I did is I did a new connection. I created a container. So a container is a term that they use when they're using virtual environments. And virtual environments are amazing because you can replicate them and deploy them and scale them much faster than physical hardware. And then you see they have a whole bunch of these selections. And it's probably worth it to just give you a little bit of context. So you can see here we have Ubuntu and version 16.4. And there's CentOS, which is another version of Linux, 7.2. And those seem to be the two major options they have. And then you have the .NET pack. So this is like a Microsoft used development extension. I'm decided to do the blank development stack with Ubuntu. So I was using the most generic boilerplate Ubuntu for this demonstration. It's not going to have any extra frills. And then these are other common packages, basically with all pre-installing the software that you would use for different purposes. For example, one that I've used before is this, which is called a LAMP stack. This is a very common for web development to have PHP Apache Apache is the thing that actually serves the web page when a request is sent to it. MySQL, which is a database program. MyPHPadmin, which is a way to access MySQL. Composer, which is an additional helper application for PHP, and Linux. That's what LAMP stands for. Linux, Apache, MySQL, and PHP. There are other stacks for web development, and Ruby and others have become popular. WordPress, for example, WordPress and Drupal are both web applications that sit on top of a LAMP stack. So this would be the same as this stack, but just with WordPress pre-installed. So I have already, click the blank development stack. I've already created that stack and it popped up. I named it demonstration instance. So I should be able to click on it and tell it to, oh, what have I done here? I want to go to SSH. All right, so I clicked my second mouse button on this, and I was able to go to the SSH terminal. Please feel free to pipe in. You do not have to follow along. This is also just can be just a demonstration. If you are following along and you have questions, please do pipe in. So what we are now seeing is a terminal screen. It'll be very similar. You'll see some differences in different ones. Sometimes will be different colors. And let me break down what you are you're getting out of this. So you're getting, first of all, you're seeing your version number. LTS stands for long-term standard or long-term release. Basically, as they release new versions of Ubuntu, every third version they pick as a long-standing supported version. So they'll continue to provide updates. And so you want to choose an LTS version whenever possible, because otherwise you'll find that you have to update within 6 months or a year and may find that your software is harder to support. So always good to use a LTS version of Ubuntu. You see when the last time someone is logged into, and you're getting my IP address. And then you get the command here. So in this case, the username and the instance were created by the system. So it's CA box is the username, which was created by this instance. And then there's demonstration-instance, which was the server name. So this is this user at this server. And then this is going to show us our location. So there's the colon. There's this little tilde option, /workspace. Tilde is the symbol in Linux terminal for your home folder. So any user who types in the tilde will go back to their home folder. The first command that I said that I would show you guys is the ls command. So ls stands for list. I'm going to now use cd ... to go down one. Well, I'll review that in a second. All right. So list, I listed in workspace. There was nothing in workspace. So I went down one directory. So there's the home directory. I was in the workspace directory, the home directory. I went down one with cd, which stands for change directory, and then ... What the dots represent is one dot is always your current directory. So if I did cd ... would be change to where you are already, which doesn't go anywhere. If you do cd ... it'll be cd down one directory. I just remember to use cd ... and that helps. You'll see that comes into play where you can specify going down directories with dots as you're trying to find addresses to files and things. So when I search here, I just see that it's workspace and it's in blue. And this particular copy, it uses colors to identify files and folders and so on. I will, if I wanted to go into that directory workspace, I would say cd, and then I could type workspace, and I'm in the workspace. I want to go back down, I cd double dot, and I am back down. The way, so now you can list to see things. So ls, I'm listing to see what's in my current directory. I can do ls slash, and then I'm going to do /l. So what I'm doing here is, this is a command, and then the -l is a flag or a modifier to that command. In this case, it's going to list additional information. So it's still listing, but now it's giving me more. And what it's saying is that the user, so this is going to be the group and user. So it's both owned and created by the username Calabox. This is going to be the file size, and there's going to be the date it was created. And then there's this part at the beginning, and the D represents it's a directory rather than a file. And then the this stands for read, write, and execute. And so you can see there's the entire, there's different levels of whether it's the system, the user, and so on. So you can see that there's read, write, execute, at the highest level, read, write, execute, at the group level, read, write, execute, and then the creator has, or it's the other way, that this, you can just read and execute. So that tells me a little bit about that folder. Now, if I don't remember how ls works and what all the flags and triggers are, it's really important to have a manual. There's a built-in manual inside of Linux, and it's called man. So if I type man and then any command like ls, it will bring up the manual page. So it's saying, what is ls? It lists directory contents. ls, then option, and then you can have file or other things. Then there's a longer description, and I'm using the key commands right now to scroll up and down inside of this. And you can see the various arguments. Now, that first one there, -a, it can be -a is short, or if you do double dash and type the word all, it's the same thing. They're just two substitutes. Generally, people prefer to use the shorter ones, but if you're learning, it might be useful to use the longer version. It says it does not ignore entries starting with a period. So there's another convention within Linux, which is that hidden files, and you remember hidden files from Windows and so on. These are files that just are not normally listed. They're often system files. In Linux, they are preceded with a dot. And so if you want to see all the files, including hidden files, you would do a -a. What else is there here? Let's see if there's anything interesting. -h, human readable. With -l or with -s, human readable sizes. For example, 1 kilobyte or 123 megabytes or 2 gigabytes. Well, that could be useful because I get overwhelmed by long numbers. All right, so I'm going to press Q to get out of the manual. So Q is for quit, as it tells you at the bottom. And I'm going to try looking at this and seeing if there's more in here. ls-a. Well, we do. We have .bash logout, .bash rc, .git config, .profile, cache, ssh. So your home directory will often have a lot of additional files, and these are where the configurations or the options that you've selected as far as what you want as your user preferences are stored. And so not all directories are going to have so many, but here we see a case where there are quite a few. And we can stack those flags that we're adding to the commands. So if I go ls dash AL, we get both A and L. Now, if you're just learning this, you're not going to see the same listed files because I have something, I had something existing in here. So you may not see all of these options when you do -A. And those, I see there's a bunch of numbers here. They're pretty understandable, but let's add -human in order to get the same listing, but now where we're up to 1,000, it's going to list them in kilobytes, and it would list it in megabytes and other things. And I'm going to want to take a look at one of these files. So we can see that some are directories and some are files. If I wanted to look at my git config, so this is a file for a program called git configuration file. I can use a text reader. Now, confusingly, in Linux, there are several built-in text readers. Different people have different preferred ones. If I'm just going to read something quickly, I like to use one called cat. And we'll take a look at, man cat. All right. So catnet files and print them out as standard output. So catenation. So there's a whole bunch of options about how you can see it. But what that means is if I go cat.getConfig, I have, it's going to display that file just right here in the terminal for me. And so what I'm seeing is user, and my username is admin, and my email is admin@makehaven.org. So now I know what's inside of that configuration file. If I actually wanted to edit this file, I could go ahead and do another program, which is called Nano. Nano's not included in all of these, so let's see if we have Nano. Nano. No Nano. So we're going to use that as a learning example, and we're going to be able to add Nano through using one of those repositories. So we've done CD, we've done LS. Let's go ahead and get Nano. What we're going to use is something called aptget. So I'm going to go man apt-get. So apt-get is a apt package handling utility for the command line. That's as transparent as mud, but there's a longer description here, and it's used in the command line for handling packages. It's the user backend tool for accessing the apt library, the interfaces, and so on. All right, so what that means is there is a software store that is managed by Debian. And for your particular kernel and your setup, your distribution of Debian, there are various software elements. That can be the software that runs a web server. It can be software that's a paint program. It can be any type of software. And those have standard names, and you can download them automatically to your computer. So I first am going to do this in a way that, well, we'll see if it works. So I'm going to do apt-get, and in the manual, it said what the commands were, and one was install. So when you say install, it's going to need what to install. And we're going to go Nano. All right, so I got a permission error. Ooh, something is wrong. Well, the thing that is wrong is that I don't have permission to modify the system as this user. In Linux, there's certain types of commands and operations that are privileged, that are more dangerous, and therefore they want to know that a user with those permissions can run those commands and modify that system in that way. You can temporarily act as a super user. So the user that has access to everything is called root. And that's across nearly all Linux distributions. So if you'll hear in like hacker movies, like he's got root, he's acting as root. And if you think of the operating system as a tree with a file system and all of the directories and all of the software branching off that tree, it makes some sense that the root is really fundamental and has access. It's at the central base of the operating system. So being root is a little bit dangerous, and it's considered bad practice to always be operating as root because you can unintentionally do something that is devastating to the system. And you might also, if you're running software as root, that software can likewise do bad things. So in Ubuntu, they have a system called super user. And you can, for just that command, say, hey, I want to act as root. And it is super user do. So I'm going to say the super user should do, acting as root, the same thing, apt-get install nano. And now it's working. And this is actually going out to the internet. It's checking the standard repository for Ubuntu. It's seeing if there's something called Nano that is in that repository. It is downloading the deb, which is that's the extension for a Debian file. It's unpacking it. It is including in the database, and now we have Nano. What were we trying to do? We were trying to take a look at the Git configuration file. So I'm going to ls. I'm going to lsa to remind myself the name. So it was called git config. And now we're going to go nano.git config. And here we are in a text editor interface where I can add note. I am adding this. Now, I'm not going to save that change because I don't want to mess with my Git config. So I'm going to click the little tilde in the menu. So one of the reasons I suggest Nano for beginners is because it does have a set of messages along the bottom that tell you what to do. There are a bunch of faster, cooler, nerdier text editors within the Linux world and within Bash. And you may find you prefer one of the other ones, especially as you grow with your abilities. But just having that little menu on the bottom, to me, is a pretty important factor. And so that's why I'm introducing Nano. So I'm going to exit. And I'm pressing the tilde is control. So I'm pressing control and X. And do we want to save the modified buffer? So this is just kind of computer nerd talk for the modified buffer is the thing that is in temporary memory that you're editing that you see right here. So this change, the note, has not actually been written to the file in the operating system. This is all operating in a temporary state until it's saved. So that modified buffer, the buffer being the memory that's holding this change state, no. I'm going to say, no, we do not want to change it. So great. It jumps out, and I have not edited that file. There's a couple of neat tricks that we can do in order to get things done faster. One is the tab key. So anything, if I did nano dot, and I wanted to get config, but it was a really long thing. So what I can do is I could type the first character, the period, and if I hit tab twice, it's only going to show me things that start with that letter. Now let's say the next thing I want is the B. So I'm going to double hit. Well, and it suggested bash. Oh, B. All right, so I double hit. So it first suggested bash, but I hit tab twice, and it's saying there's bash logout and bash RC. Now, if I choose the git config, I'm adding a G. It's the only one in there, so I can hit it once, and it's going to just autocomplete git config. When you have directories that have long names, this is great, and it allows you to move around really fast because you could type cd ... and then you can, in the new directory, just start typing the thing you want, hit tab, and then you've got it. If you forgot what it is, you start typing what you remember, you double hit tab, and it's going to show you the available options for you. Just as far as navigation, we've only been operating in the home directory, but there's directories below the home directory. So we're at tilde right now, our home directory. Let's go cd ... It takes us to a place called home. Let's see what's in home. Just Calabox. Let's go back one more. Now we can list. What you're looking at here are the file system that comes with Linux. I'm not going to get into the particulars of what each of these are. Bin, for example, is a place where it's a bin where files related to software that you're going to run go. User data is in USR. There's also MNT is mounting. When you attach like a USB stick or an external hard drive or anything, it actually creates a file that's a record of the mounting of that device. And so you'll see things like that inside of the operating system. And if I want to look at what is directories and what's not, let's just, for good measure, say with the detail using L, look at hidden files and human. And so here it is again. You see it's just completely filled with directories. And we could go into one of those directories. Let's just see what's in bin. All right. So you can see a bunch of things, including zip and file names and some other elements. I'm going to say ls, lah, and more information on each of these things. So you are seeing the color coding here indicates like your permission to access things. There's also this L. L is a link. So inside the system, you can essentially create something that refers to a different place. So these are just symbolic links or shortcuts to other places in the system. Not something you're going to have to get into, but just an FYI. I'm going to go back to our home directory. And that's just cd tilde. And now we are back in our home directory. And it shows our tilde. So that there's something more interesting, I'm going to go and create a file, an example file. We're actually going to go into our workspace to do that. Workspace, I'm using the tab. And inside the workspace, I'm going to do something called mkdir. So I'm going to make a directory. So you may not have a workspace there. And so mkdir, and that's because JR's space, put a little dash in there. So this should make a directory called JR space. So now when I list, JR space is in there. I can cd into JR space, and I'm going to add a file with Nano. So with Nano, you can go man Nano, and it's going to tell me that you had options, command line. And one of the things it will tell me is that I can type Nano and then the file name. So we'll call it JR notes text. And these are my notes. And I will actually save the buffer here. What do I want to write it to? JR notes. And if I list, you can see that I have a file with read-write permission and username, group Calabox, text. It was just created now. So those are, that's creating and editing files. So just that basic functionality is super useful when it comes to being able to go in and change configuration files and being able to access something remotely. The other thing you might do is, if you're accessing something remotely, sometimes you need to troubleshoot a problem that's happening in that system. And a nice tool just to see what's going on from a high level is something called top. So let's check out top. So it will display the Linux processes. And this will give you some instruction as to what each of the elements inside of this are, how to operate it, how to change it, and so on. Let's take a look at top. So here is top. So this is the time it has. It's been up for 57 minutes. We have one user, because Linux can have multiple users logged in from different locations at the same time. And then there's these load averages. So this is how much of the CPU is being used as a percent. And one is on like I don't remember the exact, but the idea is one's a 15-minute interval, one's a 5-minute interval, and one's like a 30-second interval. So these, it's over that period, how much is it being used? It can help you discover spikes. Right now, we are not doing anything of consequence. And then it has 28 tasks running, and most of them are sleeping. And you have your how much memory is available and free. And then you have what user is running each thing. So root has the most privileges, and you have process IDs. This just seems to be system things. If we were in another window running Nano or running a web server or PHP, you would see PHP popping up whenever somebody loaded our web page. You would see it first hitting Apache, then PHP, and whatever other processes would be happening. And you could come here and troubleshoot what's hogging all the memory. You could also then grab the process ID and do various things like kill the that process. I'm going to quit this. There's another one that gives you a hierarchical view called PSTREE. So I'm not going to go too deep into this. And for now, these are all elements of how the core system is running, and we don't need to know this. But if you were looking to troubleshoot something beyond the system and you're running some software, you might type PSTREE, and then you can see what processes are subservient to what other processes are dependent. So for example, we're running PSTREE, so it's actually a process in the system, and we're running it within bash. And then that's dependent on this, and then that's running in the system. So if anything down the tree from PSTREE were not to be working, this would be a problem, or it could kill something here and it would kill what's downstream. let's talk about a couple other basic operations, and that is to move. So if I wanted to move JR's notes down one directory, I could use the command mv. So let's go man mv. So it says to move or rename files. And the rename source to destination. And then we have a whole bunch of these options. And it would be option and then source and then destination. And it looks like there's a couple of different ways you can structure it. So we'll try moving our file into down one directory. So let's see, mv, and we're going to say source is JR notes. I use tab to complete that. And then I'm going to say ... so down one directory. And I'm actually going to name it, give it a file name. So I'm going to say new notes.txt. It doesn't give us any feedback. It does generally give you feedback when something goes wrong. So it probably went right. Let's list here. There's nothing in our directory. Let's go down one directory. And here we see we've both moved and renamed our file. Now, if we wanted to move it into JR space, let's try that. mv new notes, and then we're going to say JR space. And I didn't specify a file name here, so it will list it's gone from here. And if I go back to JR space, and I had a list command. So sometimes when you make a mistake typing something, you don't want to retype that command. So a really useful thing is the up key. The up key will bring back the last command. In fact, you can keep hitting the up key, and you can go back through the history of all the commands that you've done. So I'm going to hit the up key. I'm going to backspace. I'm going to hit, now we're in that directory. Now I hit list, and I've moved my notes up. On the note of history and past commands, a lot of times I'll want to remember what I typed. You can just type history. And it will show me the history of all of the commands that I've typed manipulating the system. Really useful for when you got something right and you're trying to remember what exactly you did right or did wrong or broke. So you might, if you're troubleshooting, go back to this and show somebody the various commands that you ran. So that is history. But we've already gotten a file from the internet. Let's try and grab another. I am going to grab an image from the internet. Let's see if this works. Yeah. So I'm going to say wget, which is World Wide Web get, wget. And then I'm just going to paste in a website address. This just happens to be an image from the MakeHaven website. There's a couple of things you can do. You can click your mouse button, your secondary mouse button, or I hit Control Shift and V. Because Control V is taken by other things in terminal, you have to use Shift when you're using Control C and Control V. There's also often a menu. So I have this long address, which is where the icon is. And when I hit enter, it grabs gives me the IP address. It's grabbing this file from MakeHaven. It's showing the download. If it was a long file, you'd see that moving. And let's see what we got. We now have a little online icon. Now, if I just type into that, it's not going to, we'd have to have a program that will open an image on here, which I haven't happened to have loaded yet. Yeah, so it's not auto-completing. I don't have a program to run that online, that online image. But that's how you grab a file from the web. So there's also copying and removing files. So if I want to copy this file, make a copy of it, it's just CP. So we'll do CP, and I can tab online icon, and I can say now a new name. So I'm going to copy it to the directory below. So ... And that should work. It should copy and use the name. So now I have it here, down one directory, and I have it there. I don't need it in two places, so now I can use remove. So that's RM, and we're going to go just ON. I'm going to hit tab. That's right. And I have now removed that file, deleted it. That gives you some sense of how you can operate the basic things within operating within Linux. There is, I'm not gonna, it's beyond the scope right now for this, but we might do it in a future session. One thing to look into is SSH. So SSH is the Secure Shell protocol. And what you would do is if I wanted to access a Raspberry Pi or any computer that has an open port and is available, I would type SSH, and I would type in the user name and the name of the machine, and then I could it would ask me, prompt me for a password, and it would allow me then to just immediately see a terminal, but that terminal is now for that other machine. So I'm using this same machine and operating it remotely. There's also ways to upload and download files and share them between machines, even something called rsync that will synchronize a directory of files between computers. But I've been going for 50 minutes, which is about what we wanted to cover. And hopefully this gives you a, able to dip your toe in the water. And if you weren't following all the way along, you can follow along in a in the recording of the video, which I'll post to YouTube. But I want to take a pause and see if there's any questions. Questions from folks? I see there's a, can you break down the MIB as to what memory verbiage is? It's best if you look that up online. So kilobyte is 1,000, megabyte is another. There's going to be a whole hierarchy, which you're better off just referring to if you search for memory and what it means. Can
I pop in on that for a second?
Sure, yeah.
Yeah, when they talk about kilo, they don't mean 1,000. They mean 2 to the 1028. A binary kilo is bigger than a decimal kilo. So if you go 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. So a kilobyte is 1024 bytes. This is a matter of reference.
Okay, yeah, thank you. I know that there are differences, and I know people get confused over bits and bytes. And my memory serves me, the bit is the individual 1 or 0, but then those are composed typically of a byte is 8 of those in sequence. And so we could get into the nomenclature of memory, but I would be a little outside of my expertise and would have to review things. Great. Well, I'm gonna stop the recording and just hang out for a minute if there's any questions.